Hi everyone, in this video we are going to learn how to find the maximum and minimum value of the function with the two variables. We will start by understanding how this works for the function of just one variable and then extend those concepts to the two variable function. Let's begin with the function that depends upon the single variable x which belongs to the certain domain D. A point is called as a local maxima if the value of the function at this point is greater than or equal to the function value nearby this point. For example, consider this graph. In this graph, if there is a peak within a small section of a domain, that is called as a local maxima. Like in this case, in this small section of a domain, the peak value is over here. It means at this point it has a local maxima. Similarly to this small section of a domain, peak value is here. It means this is called as a local maxima. However, if this point is highest in the higher domain, then it is called as a global maxima or an absolute maxima. In this case, this point is called as a global maxima as we are considering the entire domain. For the local minima, a point is called as a local minima if the function value at that point is less than or equal to the nearby function values. Like in this case, if I take a small section of a domain, in this small section of a domain, the function value at this point is comparatively minimum. It means it is called as a local minimum. Now let's move to the function that depends upon two variables x and y. The same concepts apply here. A function is called as a local maxima at the point AB if the function value at that point AB is greater than or equal to the value at nearby point. Similarly, a point AB is called as a local minima if the function value at that point is less than or equal to nearby values. To determine these maximum or minimum values occur, we need to find something that is called as a critical point. In one variable function, critical point means where the derivative of function is 0 or undefined, whereas for the two variable function, we take the partial derivatives. Means a point P is called as a critical point when one or both of the first order partial derivatives do not exist at that point. Means a point AB is called as a critical if the partial derivative of function with respect to x is equal to 0 and the partial derivative of function with respect to y is equal to 0. After calculating the critical point, we can identify whether at that point the function value is minimum, maximum or saddle point using the second order partial derivative test. Now how to apply it? So first thing we need to calculate the second order partial derivative. That is, first we need to calculate these three terms, that is R, S, T. R means it is a second order partial derivative with respect to x. T means second order partial derivative with respect to y. S means the mixed derivative, means second order partial derivative with respect to xy. After that, we need to calculate the discriminant. Discriminant that is equal to RT minus S square. That is second order partial derivative of function with respect to x into second order partial derivative of function with respect to y minus second order partial derivative of function with respect to xy, then its square. Based on this discriminant, we will have the local minima, local maxima or a saddle point. After calculating the discriminant, at the critical point, we have three observations. Either this is equal to 0 or less than 0 or greater than 0. If D is less than 0, in that case the critical point AB is called as a saddle point. If the discriminant D is equal to 0, in that case there is a no conclusion. Maybe it may have a maxima or a minima. We need some another test to verify that. And if D means RT minus S square is greater than 0, in that case it may have maxima or minima. But we need to identify what is the behavior of R. Now what is the R? R is second order partial derivative of function with respect to x. If this is less than 0, then we call that point as a relative maxima, and if it is greater than 0, the point is called as a relative minima. It is also called as a local maxima or local minima. Let's understand this concept with the help of example. Here we need to find the relative maximum and relative minimum values of this function. Function is 2 times of x square minus y square minus x raised to power 4 plus y raised to power 4. Firstly, we will calculate partial derivative of function with respect to x and partial derivative of function with respect to y. This is equal to p and this is q. The value of p is twice of its derivative with respect to x is 2x minus derivative of y with respect to x is 0 because we treat y as a constant minus derivative of x raised to power 4 is 4 times of x cube plus derivative of this function with respect to x is 0. Similarly, calculate the derivative of function with respect to y, that is twice of 0 minus twice of y minus its derivative with respect to y is 0 plus 4 times of y cube. Simplify this, 4x minus 4x cube here minus 4y plus 4y cube. Now find the critical points. Critical points are calculated as, put p is equal to 0 and q is equal to 0, means partial derivative of function with respect to x is 0, partial derivative of function with respect to y is 0. When you take p is equal to 0, we have 4x minus 4x cube is equal to 0. This is further written as 4x times of 1 minus x square is equal to 0. From here, we are getting a 3 values of x, that is x is equal to 0. From here, x is equal to 1 and minus 1. Put q is equal to 0 minus 4y outside. Remaining terms are 1 minus y square is equal to 0. This implies y is equal to 0. From here, 1 minus 1. We are getting a 3 values of x, that is 0, 1 or minus 1. Same for y, 0, 1, minus 1. From here, there are these 9 critical points, that is a combination of x and y. When x is 0, y can be 0, 1, minus 1. When x is 1, y can be 0, 1, minus 1. When x is equal to minus 1, y can be 0, 1 and minus 1. Total critical points in this case is 9. Now we need to identify at these critical points whether it has a relative maxima or relative minima. For that, we need to calculate the value of RT minus S square. What do we mean by R? R means second order partial derivative with respect to x. Means we need to calculate its derivative with respect to x again. Its derivative with respect to x is 4 minus 12x square. Value of t is equal to second order partial derivative of function with respect to y. Means we need to take its further derivative with respect to y. Its further derivative with respect to y is minus 4 plus 12y square. Value of s is equal to, that is the second order partial derivative of function with respect to xy, or second order partial derivative with respect to yx. So either take first derivative with respect to y and then take its derivative with respect to x. Its derivative with respect to x is 0. Even in this case, when you take its derivative with respect to x, that is this. Now take its derivative with respect to y, that is again 0. In this case, the value of s is equal to 0. Now here we have taken all 9 critical points. We need to observe the behavior of rt minus s square, that is a discriminant, at these points, and after that we will draw the conclusion whether it has a maxima or a minima. At the first point, when x is equal to 0 and y is equal to 0, plug x is equal to 0, y is equal to 0, this term is positive and this term is negative. Positive into negative is negative. It means discriminant is less than 0. When the discriminant is less than 0, there is no need to evaluate r, and we can directly say that it is a saddle point. For the second point, 0, 1 means when x is equal to 0, this is positive. When y is equal to 1, this term is again positive. Positive into positive is greater than 0. In case discriminant is greater than 0, we need to observe the behavior of r, and r is equal to 4 minus 12x square. In this case, at this point is positive, it means r is greater than 0. So this point is relative minima. For the next case, x0 positive, y minus 1, that is positive. Positive into positive is term is greater than 0. If this is a greater than 0, observe the behavior of r. R is greater than 0. It means this is again a relative minima point. For the next point, 1, 0. Substitute x is equal to 1. This term is negative. 0, again negative. Negative, negative is positive. Discriminant is greater than 0. So observe the behavior of r. R in this case is this term, that is negative. When discriminant is greater than 0 and r is less than 0, it means it is a point of relative maxima. For the next case, when x is equal to 1, this term is negative. When y is equal to 1, this term is positive. Product of negative positive is less than 0. Discriminant is less than 0. There is no need to observe the behavior of r. It means it is a saddle point. For the next point, 1 minus 1, plug x is equal to 1, this term is negative. Plug y is equal to minus 1, this term is positive. Negative positive is less than 0. Discriminant is less than 0. We can directly say it is a saddle point. When x is equal to minus 1, 4 minus 12 is minus 8, that is a negative term. Y is equal to 0, negative. Negative, negative is positive. If discriminant is greater than 0, we need to observe the behavior of r. R is negative. Discriminant is greater than 0, r is less than 0. It means it is a point of relative maxima. Next critical point is minus 1, 1. At x is equal to minus 1, this term is negative. At y is equal to 1, this term is positive. Positive into negative is negative. Discriminant less than 0, it means it is a saddle point. Next point is negative 1, negative 1. When you plug x is equal to negative 1, we have negative term here. Y is equal to negative 1, this term is positive. Negative into positive is less than 0. If this is a less than 0, it means it is a saddle point. In this case, we are getting a 5 points. They are acts as a saddle point, means neither maxima nor minima. But there are 2 points with a relative minima and 2 points with a relative maxima. We can also calculate the function value at these points. At these points, we are getting these function values. It means at the relative minima, the function value is minus 1. At relative maxima, the function value is 1.